Hello again, everybody. Joseph, and this is continuing one time where we spoke about the very important sensors. When you have a scan tool, even in something called open loop, in the beginning, you always pay attention to intake air temperature sensor, throttle position sensor, especially engine coolant temperature sensor. So I was asked this question about grounds for these devices, and I was asked a question about how do you know if it's 5 volts or 12 volts. Now, it's very important to understand, what are you supposed to measure? Number one, am I supposed to measure 12 volts? Am I supposed to measure 5 volts? If I'm supposed to measure 12 volts and I measure 5 volts, obviously there's a problem. If I measure 12 volts and I measure 9 volts, that means it is loaded down. There's more current being drawn. So it's very, very important to understand when you go to that connector, to understand is B plus 12 volts or 5 volts. Now, looking at the schematic over here will not actually tell you all the details. For example, you have to figure it out. But when you go to the information of the connectors itself, if you have Haynes or if you have Mitchell or Data, they will give you obviously that information. Number two, as we spoke about, the grounds. The grounds over here, these are grounds given by the computer. This is the actual schematic, this is the actual book from the dealership, from Chevy's. And therefore, when you come over here, all this is part of, the dotted line represents a part of the many wiring of the computer called the PCM, Power Control Module. Pin 57, pin 24, pin 60, pin 80. So therefore, this, when it says low reference, that means this is giving me, the computer is giving me a ground. Maybe there's a transistor that goes to ground, a switch, whatever it is. We don't know what's in here. But it's irrelevant to us. We don't really care about that. All we know is we're getting a ground. As opposed to this ground, the physical ground. Whenever you see G105, this is a physical ground. Okay, so keep that in mind. One is from the computer, one is a physical ground. Now, I'm looking at the schematic. As I said, I have no idea what voltages I should be looking for. Let's try to figure it out from the information that was given to us. Power control module, again, here's the other part of the computer called power control module. Pin 74, pin 8, pin 25. The dotted line means part of this module computer has other parts to it. And here's the other part to it. A dotted line around it. It can have 200 wires or more to it. So therefore, let's try to use basic electronics to figure out, do I get 5 volts or 12 volts? Let's take, for example, throttle position sensor. This, if you saw a video, is called a potentiometer. A potentiometer is a variable resistor that you can change, going clockwise or going counterclockwise. The voltage related to that, when you change it either clockwise or counterclockwise, will change in relationship to that. So if you look at this over here, we know the power control module, which is a computer, is getting 12 volts. We know that, let's say, from one point to another point, do we have a voltage drop? Did we lose a voltage drop? For example, from here to here, it's a straight wire. We're not going to lose any voltage. From here to here, it's a straight wire. We're not going to lose any voltage. So if I measure 5 volts here, how much should I measure here? 5 volts. If I measure the other side of this sensor, right? Let's say B over here or A. If I measure 5 volts here, how much should I measure over here? 5 volts. But this is a low reference. That means this is a ground. This is 0 volts. 0 volts here, 0 volts here. Now, taking that into consideration, I just made a statement and said, this computer works on 12 volts from the battery. So we have 12 volts over here. We have 12 volts over here. But what do we have here in between this point and in between this point? We have a resistor. That means I expect to lose some voltage across this resistor. How much will I lose? Let's figure it out. I know I have 12 volts here. I know this is internal. These resistors are inside the computer. See? Whatever is inside this dashed, actually dotted line, means it's internal in this computer, in this module, let's call it. This resistor is in the dotted line, it is in the computer. This resistor is in the dotted line, it's in the computer. Okay? So really, it's not our worry. However, for practical purposes, I'm trying to explain to the viewers, voltage drops, it is our concern right now. 12 volts here. What do we see over here? 5 volts reference. That means this point that it's telling us is 5 volts. How much did we lose across this? If this is 12 volts here, this is 5 volts, I lost 12 volts. So therefore, the 5 volts is the reference for the TPS, which is a throttle position sensor. So therefore, this can go as high as 5 volts. That's as much as we allow it to go. Now, again, turning the wiper, this is the wiper. If you turn it one direction, or you turn another direction, or you turn it this direction, counterwise or counterclockwise, there's going to be a midpoint. So what's the middle of 5 volts? 2.5 volts. What about when I move this resistor, I turn it, the wiper, which is called the wiper, the mid arm, will be over here at this point. And what's this point? Ground. It'll be 0 volts. We're going to toggle from 5 volts, maybe to 2.5 volts, to 0 volts. However, sometimes you're not even going to be at 5 volts. Maybe you'll be less than 5 volts. But for schematic purposes, we're going to look at this and we're going to say, okay, so I expect to get at a TPS 5 volts as a B+. This is the B+ line. This is the control line. The control line gives the sensor signal. Whenever you see sensor signal, that means this one is giving back the information to the computer where this sensor is voltage-wise. And the computer knows 4 volts, 2.5 volts, 3 volts, what it represents. When you put your foot on the pedal, on the accelerator pedal, the gas pedal, there is a cable, or sometimes now it's a sensor. It goes to something called throttle position sensor. And that opens up the plate in the throttle position, in the throttle body, to allow more air. How does the computer know? It looks at this, and this gives it voltages. 2.5, 2.4, 2.3, and it says, okay, I know how much that plate in this is being opened, and also the angle of it. So therefore, this is the control line. See, whenever you said signal, sensor signal, that means that is a control line that is giving back information to the computer. Now, so therefore, we established the fact this is 5 volts. Why? Because we dropped 7 volts across this. Let's look at this one. 12 volts here. Over here also. It did not tell me 5 volt reference. But I do see an internal resistor. That means I dropped something over there. That tells me that this is likely to be 5 volts. At this point. 5 volts here. 0 volts here at the low reference. What's this symbol? Meaning that the resistance changes with what? With temperature, with coolant temperature. The hotter the coolant, the lower the resistance, the lower the voltage. This will drop from 5 volts or wherever it starts from, 3 volts, 2 volts, 1 volt, whatever it is, it's going to drop as it gets hotter. A thermistor with, it's called negative coefficient. It's going to drop the voltage. That's a good sign. We want to see that. So if you put your scan tool, you'll see the temperature, you'll see the voltages change, go down. That's a good sign. So therefore, I expect to see 5 volts here. Okay? Now, we said this is 5 volts, this is 5 volts for this one. Okay? Again, intake air temperature. I get it, let's say I go put the scan tool on and I get a code for intake air temperature. Will I just change the intake air temperature? No, I'm going to go to that connector. I want to make sure that I have B+. Before I do anything, and then I have a ground. But do you know what the voltage will be? Will it be 12 volts? It cannot be 12 volts because there is a resistor here. So I expect to have 5 volts. Again, 5 volts here, and this will be 0 volts. Why? Given me by the ground of the computer. Again, as the resistance changes, this tells you the resistance changes with temperature. The voltage will drop. However, as I specified before, the temperature, when you have the hood closed, the temperature, it'll get hotter and hotter and hotter compared to the outside air. So keep that in mind. So therefore, 5 volts here. Why? Because there is a resistor here. 5 volts here. Why? There is a resistor dropping here. About 5 volts here. Why? There is a resistor. Okay? Same thing over here. It gives you 5 volt reference. That means the highest it can be is 5 volts. When I turn the wiper in one direction, it'll be connected to 5 volts. If I turn it all the way in the other direction, I'll be at 0 volts. Where is the signal sensor for this? Where is, out of all these three, right? C, A, and B. Which is the information back to the computer? This one. How do I know? Sensor signal. How do I know it gives back the information to the computer? This is the computer. See? And out of this also, out of A, B, and C, how do I know which one is the B+? I follow the line. It goes up to this one. How do I know which is the ground? It goes to this one, B. How do I know which gives back the information to the sensor? This one. You go to pin 24. Again, tomorrow the weather is going to be nicer. We're going to go and do things outside. I'd like to thank the actually subscribers. Last month I had a pretty good one, 100 subscribers. For me, that's great. But also I had like 15,000 minutes viewed. So slowly but surely, I guess the channel is catching on. Now let's look at the most difficult one, mass airflow sensor. You could really go into detail about this, but I'm not going to go into that much technical because you know why? Mass airflow sensor is a sensor that shows you how much air is being drawn through the air take chamber. And we spoke about this before in the video. Coolant, engine coolant, how hot the coolant is getting. This is information to the gauge in your instrument panel where you have the temperature gauge telling you how hot it is, coming from this information. Now, this one over here is a little complicated, like I said. This is a feedback with transistors, NPN to NPN. This is called a Wheatstone bridge. There's supposed to be the same voltages across it to balance it out. But when this gets drawn by air, it changes the sensors over here, the resistors. And the current changes and the voltage changes. This is an output to this. This is like a differential amplifier. And this will change this output and a feedback back to this to make sure that this is balanced. I don't want to get too technical because I'm going to lose viewers. I'm trying to gain viewers, not lose viewers. But anyway, again, C, B, and A. Now, which is the B+? This one. How do I know? Look, it goes through a fuse. How much should I measure over here? In the other ones, we have 5 volts. How much should I measure here? Remember the other one, the difference? We went through a computer. Look at this one. We're not going through a computer. What are we going through? We're going through the fuse panel. How much should be over here? 12 volts. Why? Because it's going to the battery. How much over here? 12 volts. Why? I'm not losing any voltage. Does the ampage have to do with me losing voltage? No, I don't care if it's 5 amps, 6 amps. As long as this is intact, this fuse is intact, 12 volts here, 12 volts over here. Now, again, this is a dotted line representing there is more to this fuse block, probably in another part of a diagram. So, did I lose any voltage from here to here like we just learned? No. That means if I have 12 volts here and you agree that you have 12 volts over here, and this is just a wire, I should have 12 volts over here at C. What about the other one? Let's go to B. What is this going to? Ground. What is ground? 0 volts. 0 volts here, 12 volts here. We just got 2 out of the 3. But we need one more thing. That's a control line. We need something to tell the computer. Remember what mass airflow sensor is telling how much air is being drawn. How much mass. Not volume, but air. The weight. In grams per second, if you see on the scan tool. How much does it know? Where is that information going to go? Is it going to be... Is this the information for the computer? No. It's a B+. To give this module. Is this going back to the computer? No. It's a ground. Well, there's only one left, right? There's only one line left. That is A. Follow A. Over here, A. Sure enough, sensor signal, right? And sure enough, what's the dotted line? The power control module, the computer. So therefore, what is the feedback? What is the control line? This one, A. So if you look at the actual sensor, C, A, and B, the one that's giving the information how much air is being determined is A, to pin 31 of the PCM. The PCM needs to know all the information. PCM needs to know how hot the coolant is, the air temperature, how hot the temperature is, cold or hot, how much air is being drawn. All this information is the vital information. As soon as you turn up that car, it has to know, that computer has to know that to match the correct fuel ratio to it. So therefore, again, this is the output signal. Whenever you see sensor signal, it's this one. Again, the question is, and we spoke about 5 volts or 12 volts. This is 12 volts because it's going right to the fuse. This is 5 volts. How do I know? I have a dropping resistor. This is 5 volts. How do I know? I have a dropping resistor. Dropping resistor. Okay? Anyway, thanks for the subscribers. And like I said, I made a video about that scan tool that's really pretty cheap for $100. Please watch that one. And subscribe to the channel, Automotive Electronic Schematics, and the other one, Joe Electronic Schematics for auto. Like I said, I appreciate it, and hopefully I'll be making more videos outside, and you'll see how first we started. First, in order to understand electronics, to do electronics and to diagnose, you have to understand the basics of how the electronics work. When I go out there and I measure 12 volts and 5 volts, I cannot really take the time and say, okay, how much should I measure 12 volts or 5 volts? This is why I do the schematics in electronics first. It's not like mechanical where you just do brakes and transfer cases and things like that. There's no preparation for that. This needs preparation. Electronics needs preparation. And when you go and you see a signal back to the PCM, you have to know, hey, if I tell you this is A is going back to the computer, then you understand what I'm talking about. If I tell you C is 12 volts, you'll say, okay, I remember he spoke and he explained to us it's going to the fuse. That's why 12 volts. If I go and I measure 5 volts over here, when we do the hands-on, you'll say, why is it 5 volts, not 12 volts? Why? Because it's going through the PCM. And there's a dropping resistor, so it's supposed to be 5 volts. If I go to a map sensor, which is pretty hard to get to, but if you go to the connector and I measure 5 volts, you'll say, why isn't he measuring 12 volts? Where? Because he's not going through the fuse, he's going through the PCM through a resistor. This is how you know. That's why you have to have preparation before you go out there. Okay, thanks for watching. Again, watch that video, please, about the scan tool. Try to get familiar. And $100 is a good value. So anyway, thanks for watching.